Welcome to the world of fiber optic communication networks.
We have seen attenuation and dispersion in an optical fiber, which plays an important role in optical fiber networks.
Excuse me, ma'am. I understood what you said, yet I have not seen these fibers and lasers. Can we measure this attenuation and dispersion in our lab?
That's a good idea to do in lab, but we don't have any facility. I will definitely try to find out how it can be performed in lab.
Good morning, sir. Can I come in?
Yeah, please come in, Alpana. Have a seat.
Thank you, sir. Sir, I'm done with all the arrangements for temperature and pressure check. Sir, I just want to check fiber optic sensor response.
Oh, that's wonderful.
I'll need this laser source with power control and detector to check the sensors. Well, can I get some?
Oh, then we have to order these components.
Oh, so I just want to test the performance. I just want to make some modifications if required. So this new order will take too long, and I'll have to make all the arrangements of electronics again.
Yeah.
Can't we purchase ready-made?
Yes, but it will be expensive and we don't have enough budget for it. Every now and then we are in need of these optical components. Last time I remember you needed circulator and a BG.
Yes.
I have to find some solution for it.
Yes?
Sir, there is a problem in the fiber optic network in New Delhi. Can you send some expert immediately?
Okay, I will send one engineer to New Delhi right away. Ravi, there is a problem in the fiber optic network at New Delhi site. You have to urgently go there and fix it.
But sir...
See Ravi, your immediate task is to fix the problem by locating the fault in the fiber optic network. And probably you must check some I pattern for OSNR at the site.
As you know, sir, I have joined the company very recently and I have good theoretical knowledge, but I don't have any practical experience in this field. Can I get some training before going to the field?
I cannot keep all these expensive equipment and instrument for just sake of training and demo in my lab.
But isn't there any alternative arrangements for this?
Probably I may have to do something in this regard very soon. I think next time you would be better prepared to handle all this.
Okay, let's talk about something important. We are presently implementing WDM technologies and EDFA systems in our networks in order to increase bandwidth. But surprisingly, we've been to several industrial meets, but we have failed to find the necessary manpower with the required hands-on experience.
That's interesting. This state-of-art technology is included in our syllabus and we rigorously teach this to our students in the classroom.
Yes, madam, but theoretical knowledge is one aspect. Industry requires hands-on experience.
Yes, I agree with this. But unfortunately, we are in such a scenario where we don't have these facilities.
We welcome you all to Fiber Optica Technologies Private Limited. This is our solution to all the problems you have. This is Light Runner, a fiber optic communication benchtop laboratory with WDM, which has laser sources and detectors along with passive optical components. Moreover, it has a PC-based software control.
I've seen many fiber optic kits, but those are all demo kits. But what about Light Runner?
Light Runner is the world's most extensive fiber optic communication benchtop laboratory with WDM. Each experiment in Light Runner requires quantitative measurements done, either using the DSO given along with it or using the photo detector output display in the software. In this way, Light Runner is not just a qualitative demo kit but an absolute quantitative measurement solution.
What are the laser sources and detectors provided in this?
Light Runner is a fiber optic communication laboratory and a standalone system which requires only 230 volts or 110 volt AC for its operating. All accessories required are provided with it. This has 6 pigtail lasers, out of which 4 are DFB lasers in C-band at 1510, 1530, 1550 and 1570 nanometer, each with 1 milliwatt output. Others are 20 milliwatt 660 nanometer laser and 80 milliwatt 980 nanometer laser. It also has 4 infrared in-gas pin detectors and 1 visible silicon detector, followed by transimpedance stages. Besides, 1 more in-gas detector is provided, having an adjustable gain facility.
It is really useful for us.
Exactly.
That's good. But do you have any control over laser power and modulation?
Yes, of course, we do have it. As I mentioned before, Light Runner has a front-end software running on a PC which controls all the lasers. Moreover, we have options like digital and manual power control. Digital power control is using front-end software on notebook. An external knob on front panel gives options of manual control. Except 980 nanometer pump laser, all lasers can be modulated with frequency from 0 to 2.5 MHz, and even duty cycle of modulation can be changed from 10% to 90%.
That's really very good. Can I have a closer look at the front-end software?
Why not, sir? Light Runner software can be opened by clicking an icon on the desktop, and it appears on the screen. This gives you a list of experiments on the left side, as you can see here. Once you click on the name of the experiment, you will come across the corresponding introduction, aim, block diagram, observation tables appearing on right hand side. One can go through it before performing an experiment.
Oh, that commodity is fantastic.
Thank you very much. Now,